So, hello to everyone, and let's start our presentation. Today, I will discuss the cloud forensic readiness. During our promise course of advanced forensic, we'll cover a bulk of different advanced topics. But today, the cloud became a more significant part of infrastructures. It doesn't mean that everyone just moving to the cloud, etc. No. We could have a hybrid environment or fully cloud-based environments, whatever. But that's why we need to be ready for incident response, to correct incident handling and response. It means that we need to establish procedures also for forensic. And today, the forensic inside the cloud became a challenge because we have a bulk of limitations. We have a bulk of specific cases, or we have additional layer of management, etc. So let's discuss the cloud forensic and what are the challenges of it. And first of all, I would like to start from the cases. And previous year we have a total cloud related case. Name it Solar Gate, or remember this, SolarWind, etc. So for today, it's really not known what was the core reason, what was the root cause, or it was stalling the SAML seeding key, yep, or it was the obtaining the admin privileges, and they have possibly they have created a new SAML thinking key and modified the Federation of Trust. But whatever, at the end we have SAML means SAML tokens. So attackers, what is the SAML? It's a part of SSO. Yeah, it's a protocol for a single sign-on process. They have access to the cloud resources. They had access to the cloud resources. They have searched for accounts of interest. And what's very interesting, they have found that this cloud have used different applications for OAuth processes. OAuth, it's also protocol for the single sign-on, and it has it processes the privacy data, credentials, etc. So how it was? They not compromise the existing applications. No, they have created a new applications. They have that was impersonated. They have assigned for them a special service principal. What is this service principal? It's an account or role for applications to manage access to the cloud resources. So when you will register application inside the cloud, you need to give them permission. You need to give them account to be able to access the sources. So they have created a special service principles for them and launch these applications as legal single sign-on for applications for with OAuth support. And with help of these applications, they have gathered the bulk of emails and extracted them through the special APIs of these applications to the command control center. So this is a totally and fully cloud-related case. But today, cloud forensic should be the same as standard process because it's a formalized process. And we have the same stages: acquisition, preservation, examination, analysis, and reporting. But in cloud, all these activities became more and more challengeable. Why? Because we have a set of limitations, challenges, restrictions, but additional possibilities. Let's talk about the challenges. National Standard Institution has provided a document 8006, which describes forensic challenges inside the cloud. Take a look. We have architecture challenges. In case of incorrect architecture, it will be impossible to gather the data, to obtain the data, even to track the penetrator. Data collection. If we will miss some tools or misconfigure these tools or can't access the license with these tools, we will not be able to gather the data. The same with analysis. Okay, the question is, if we have 5 terabytes of the data, how we could analyze them? Of course, not in the premise architecture. We need to have, let's say, we need to have a special environment in the cloud to analyze this data, this bulk of data. And of course, different anti-forensic techniques: obfuscation, encryption, hiding, impersonation, etc. Also, I would like to talk about the data collection as a challenging process, according to the fact that even inside one cloud, sometimes it will be impossible to collect the data from the sources from another region, and mean that because it will take a lot of time and money. The same question for the first responders: who will detect the incident? Which tool will detect the incident? If we will not have established an, let's say, special monitoring, threat modeling, threat tracking, etc., will miss the incident. And of course, legal restrictions, legal limitations devoted to the jurisdiction, devoted to the data transfer, cross-border data transfer. Take a look. It's impossible and restricted to transfer the hard drive image if it contained a personal data from one country to another, because according to the jurisdictions and legal limitations, it's restricted to transfer the personal data across the borders. That's it. And of course, lack of standards, lack of training for the employees. And on the right side of the slide, you could find the table with examples of these challenges. Deleting, for example, challenge deleting in the cloud, or recovering overwritten data, and this, with full description why it's challenge and result if this challenge will be overcome. But this standard, NIST IR 8006, contains a bulk of such examples, and I extremely suggest you to be familiar with this standard, to be ready when you will conduct your forensic, or you will prepare for your forensic inside the cloud environment. If from the forensic challenges inside the cloud, we could move to the forensic readiness, to the factor of the forensic readiness. And Cloud Security Alliance today represents and 3 categories of the forensic readiness: technical factors, cloud infrastructure, cloud architecture, forensic technologies, cloud security tools; legal factors, SLA, regulatory jurisdictions; and organizational factors, support of management, strategy, governance, and culture. What about the technical factors? Take a look. As I already mentioned, architecture is a key, but also the tooling, the cloud security is a key, and the types of infrastructure also is a key. Because if we'll have different type of hard drive, for example, it will be impossible to make a snapshot from that. That's it. The same with SLA. The same with regulatory and jurisdictions. I've already provided you and some examples. And organizational. Processes and people should be familiar with the tools, should be familiar with the standards, processes, and so on. For the infrastructure and architecture, I would like to emphasize that the modern cloud provides us an additional possibilities and capabilities to automate the forensic process. And in today's lecture, I will cover these topics and will give you some examples. And if we talk about the different models, take a look. We have a research from one of our colleagues from BTHO that they have analyzed different articles, papers, research papers, and compare the description of the different factors inside these papers and necessity of these factors inside during the forensic process. And please take a look that we have technologies, security, jurisdiction, and procedures as primarily the most faced, let's say, factors during the forensic process. But architecture, infrastructure also is important, as well as what else? Or maybe training, but not so significant. And I would like to give you some examples with modern cloud and example of the Azure. One example of architecture from the development company, which today is delivering and still delivering the product to the big tobacco company. And they have a lot of resources, mostly focused on web services and CI/CD, continuous integration, continuous delivery of these services. And they had a very good network architecture and system architecture, who have provided for them a great schema how to monitor and how to be ready for the incidents. And based on this example, I would like to emphasize that we have, according to the this technical points, we need to take into account three tautology, 3 points: architecture, licensing, and technologies or tools. Take a look. The resources the main web services are delivering with AKS, Azure Kubernetes Service. It's an orchestrator for containers, and VM and VM set, virtual machines and set of virtual machines, which contain the databases and some additional tools to monitor all these devices. Architecture has provided the next tools. First of all, it's built in Microsoft Defender for Cloud. It looks like a big Hoover, which collects all the data, all accessible, configured from all configured sources, and analyze them according to the compliance, to the inappropriate using, let's say, attempts for unauthorized access, etc. But to deliver such kind of data from the load balancer or not network access table gateway or even IP manager, it should be established additional tool named Azure Monitor. And please take into account that if you talk about the logs just as a source, even in such not big infrastructure, we have 2 types of logs. First type, it's resource logs. So actions from the resources inside the virtual machines, inside the containers with applications, inside the load balancer, etc. So the logs from the resources, and activity logs, all activities in the environment, so in the cloud. For example, creating new IKS cluster or creating new virtual machine, it's an activity log. But SSH access attempt to this machine, it's a resource log because it should be tracked and covered inside the virtual machine, etc. To gather this data, Azure provides additional connectors. For example, AKS connector or Linux connector, Windows log collector, etc. So the data from these resources, let's say main and services sources, are captured inside the Azure Monitor and Microsoft Defender for Cloud, which will generate the alerts in case of some misusing, etc. But these tools are not able to analyze and monitor what? Storage accounts. For example, to prove the absence of the malware, or to detect the malware in case if some user will upload or execute it. So we need additional tool, Microsoft Defender for storage, which will cover the storage account, which will analyze and track the malicious activity. If we have functional applications, so access function, type of resource, name it function as a service, there is no connector to the Microsoft Defender or Azure Monitor. So we need to have additional layer with named application insights, which will generate the data and forward them to the Microsoft Defender. But that's not all. If we would like to gather the network data, even inside the cloud, yep, we need to establish a new tool named Network Watcher, which is regional related and regional based. So it's impossible to create one Network Watcher for all regions that you have resources. You need to create separate Network Watchers for each region. And this data network flows, mostly, of course, it's could be or net flow or pickup flow, should be gathered into the Network Watcher, and after that, or stream it to the Microsoft Defender, or should be additional to, for example, Azure Sentinel SCM system, which will capture the data as well as from network data sources, as well as from Defender. We're talking about the logs, talking about the attempts, activity, and so on. And okay, this looks like I was clarified architecture and technical tools, but what with the licensing? It's money. Take a look. Security Center as part of the Microsoft Defender is free, but if we would like to have a Defender for Cloud to gather the data from virtual machine scale, say at AKS, we need to pay. For example, 2 cents for server per hour. If you talk about the Defender for storage, it's a 2 cents. Of course, it's all these prices depends from the region. I was using the US West region, just for example clarification, but it could be different in different regions and different data centers. So Defender for storage, 2 cents per 10,000 of transactions. If you talk about the Azure Monitor, we need to store the logs, yeah, and by default the logs has retention policy for 30 days. If we would like to store more than 30 days, we need to pay around 14 cents per gigabyte per month. All right. The same situation with log analytics, $3 per gigabyte for analysis, 1 per day, etc. In case of Network Watcher, it's a bulk of configuration, and I'll list it on the right side of the slide. And you see that if just we would like to collect the logs, it's, for example, 50 cents per gigabyte. If we would like to connect everything, to analyze all connections, it's also additional prices, etc. So licensing and so on. But if you will choose the right architecture and you will choose the right tools and specify what exactly you need in case of most risky incidents, you need to conduct the forensic. Of course, you could move forward with it. And how it will look like? First, of course, automation of the detection. We have an example from the Azure Security Monitoring. Yeah, we have malicious activity, alerts, and of course, the cloud provides a very good approach to deep dive inside from one point to deep dive to the logs, to the specified record, etc. How it alert looks like. For example, we have notified that we have one incident with suspicious PowerShell activity. All right. But what about the raw data? What about the gathering the digital evidences as evidence, which could be present into the during the court process? Logs inside the Sentinel or inside the Microsoft Defender for cloud, it's not an evidence. We need to have additional data and to gather, preserve, and analyze and present. Even Azure documentation provides you with some solution according to the architecture and tooling. Please take a look. We have different subscriptions as highest level of Azure access. We have subscription for the production, and you could see that we have VM01 here is, yeah, and we have attached VHD data drives. So this drive isn't built inside machine, but it's attached. Why? Because attached drive is possible to provide a snapshot, to take a snapshot. So we have virtual machine as a calculation resource. We have attached hard drives. Yep. And we have special subscription for the security processing centers, which are ready to snapshot these drives, to transfer it between the subscription, preserve, and analyze. It's a, as I said, it's an example from the Microsoft documentation, and you could find it on the official page. But about the snapshots, all right. How to do it maybe automatically, or how to, if you talk about the analysis inside the cloud native environment, that's the trend today, that it's not necessary to download the snapshot, analyze on the on-premise machine, but you could analyze it inside the cloud also. But if we still need it, how to do it? And it's also a challenge, as we could see. It's not so easy to make a snapshot and download it. And even today, some activists have provided their run books how to do it. In one architecture, I would like to present to you. Here we go. So to download the snapshot to the hard drive, or to upload it to the other Azure account or other subscription, you need to, first of all, create a snapshot. The drive should have additional configurations to be able to do it. You need to have your shared access storage. So in your native account, you need to have a service as shared access storage to place this snapshot here, yeah, or to place some additional data here. And how to do it, how to process additionally. There is no direct access to do it. And today, there's a special approach in Azure named disk from URI. So how it's possible? There's additional tools which not just download the data, but they will create the similar byte-to-byte disk inside the or additional storage, other storage account, or inside your on-premise machine with functions named create disk from URI. So you need to provide a URI of this snapshot in your shared account storage, and it will be downloaded and recreated with the same byte-to-byte string and the same hash as well. And today, you could automate these processes with built-in functions. And be honestly, Azure has such kind of functions, but they are a little bit complex and complicated. And the competitor of the Azure is AWS, has a much more, let's say, comfortable way to work with these functions and to configure it. And I would like to present how to do it in AWS also. So I just explained to you which tools could be used to provide incident detection response and could be useful for storing the data during and analyze the data during the forensic process. In case of AWS, we have looks like the same approach because it's a cloud architecture. First of all, we have AWS organizations. This similar to Azure subscription, yeah, and it looks like a sub account which could be isolated from the main. In case we need to isolate the machine or restrict access to it or save its state, yep, for current time, we could use such configuration named security groups. What does it mean? It's a virtual group that you could provide policies. So, for example, no one have access, no network, no direct, no with web panel, whatever, for these resources that are present in these groups. And you could configure your security orchestration or automation response tools to, in case of malicious activity, for example, with high risky preservation, we could automatically place the suspicious resource inside the specified security group with isolation. It means even hard drive, it will be frozen. Even hard drive will not be changed from this moment. And it's very important that you could froze the state of the data as well as memory. It's today AWS provides such kind of function, so you could have access to the hard drive and memory on the specified time. It's unbelievable. What else? Of course, if we need to have an network data, we could use VPS flow logs. This tool is similar to the Network Watcher or NetFlow tracker, whatever. We could obtain the network data from our network interfaces. If we need to, let's say, to analyze the activity logs, we could have our Cloud Trail or Cloud Watch. Remember, we discussed activity logs as well as resource logs. So one of these Cloud Trail is responsible for resource log. Cloud Watch is responsible for activity logs. In case of AWS, there are two different tools for this. And what very interesting in AWS that we have 3 additional tools that quietly useful for preservation, for capturing and preservation of the data. First of all, it's AWS step functions. It's automation steps that could be created and executed during the incident automatically. Remember, I've told about the security groups. So you could create a function that will be executed with the Cloud Watch or Cloud Trail. In case of some incident, it will move the resource to the security group, or create a snapshot of it and place it to the special service named S3, Amazon S3. It's a storage for a snapshot, artifacts, maybe binary data, blob data, etc. So flow, as I said, function will be automatically executed. But if we need to analyze analyze the artifacts, if we need to provide this cloud forensic automatically, do we need to have a special laboratory or special environment to analyze this data? Or this environment could be created case by case. So when we need it, when we have an incident, yes. And for this, a very useful tool named AWS Cloud Formation. It's a tool for automatically create the environments. If you're familiar with the approach named infrastructure as a code, that's it. Looks like the same. Looks like ARM templates inside the Azure. So it's a code in JSON presentation, which describes what we need, what resources, tools, operative system, our system need to have, and which functions should be executed. That's it. So we need to, in case of we need to provide automatic forensic analysis in a clean environment, for example. All right, we could create this environment by case. No, we don't need to store it or have reserved resources. And how it looks like, for example, snapshotting the tools. So we have a monitored account in AWS, and we have GuardDuty, a tool which is extensible for the Cloud Trail and CloudWatch, gather the data from this. It looks like it looks like a CM system, something like that, and it manages the threat detection and can provide continuous monitoring and so on. So CloudWatch, Cloud Duty, sorry, has detected the incident, and it's so that it's a member of our security hub or etc. All right, administrator account or administrator function will be identified. All the data will place it to the Amazon event bridge, and event bridge rule, the rule how to process the data and what needs to be executed, will execute the Lambda functions, which you could create in Azure Step Functions. Here we go. And after that, these functions will obtain the role of member automation. It's a special role in RBAC model for AWS. It will access to the compromised instance, get access to the EBS volumes. It's a hard drive. Yep. For example, check it or decrypt it in case it's encrypted, etc. Create additional volume, yep, and copy all the data to the volume, byte to byte, and place it into a special bucket inside S3 storage account. So, if you talk about the functions that need to be realized, you could find examples of them here on the right side. It's a copy snapshot. Check this copy by hashing, because sometimes this function needs to be doubled, yeah, in case of some bit flipping or whatever. Sharing to place to copy from the another source to the another source. Yep. Check this copy. Create volumes, provide byte to bit, etc. Take into account that the golden forensic rule do not work with the original evidence, should be maintained here also. So you need to have not one copy of the hard drive, but at least two, golden copy and working copy. So you need to the good approach to have two different buckets of S3 storage. So a golden evidence bucket with copies will not be touched and processed, and the working copies. So if you need to have additional copy of the hard drive as evidence, you need to copy from the golden bucket, but not from original evidence or original snapshot of hard drive. That's it. What else? And you could, of course, automate all this process, not only for gathering the data, but also for analysis data, launching the tools, launching the even the Sloth Kit as tool could be automated inside the AWS. So you could find the way how to automate it on this link, and I suggest to visit it. Here we have the example of security account with special forensic virtual computers, which will be placed in different private subnets. Yep, gather the data from S3 bucket to obtain obtain access to the hard drive in them, and so on. Also, there is an example how to create a special clean room. Yep, for the hard drive, or other example how to process the automation, how to automate the process of analysis. Take a look. When we have one incident as topic, we have instance, virtual machine or cluster or whatever. We need to verify it and provide the automated functions, automated steps. Remove auto-scaling. What does it mean, auto-scaling? In case of we have VM scale set as type of resources, it will scale if it will need additional resources. So we need to restrict this access. We need to limit resource which already are in use, because sometime when we will execute the forensic during our process, the malicious activities be still executed and will require much more and more resources. So first of all, we need to change the configuration, remove the auto-scaling. We need to create a snapshot of the volumes, as we also already mentioned. We need to record metadata of this machine or this resource, for example, data of last access, role-based assigned roles, assigned permissions, maybe some limitations, etc. We need to apply the tags for this machine or this resource. For example, suspicious that no one other or no any automation tool will access to it, because sometimes in cloud environments we have automation tools, for example, Terraform, or widely used in different developer companies, or some other orchestrator which will manage the machines, disable, enable, create new, and we need to create a special rule. If this machine or if this resource has tag suspicious, it should not be touched. It should be isolated. That's it. So after that, isolation, creating clean room with CloudFormation, as I already mentioned, yeah, and automatically run by the basic forensic, for example, Slothkit or Autopsy or whatever, even the generation of report and delivering the report with any way, for example, with Slack or mailing, whatever. So take a look. This is an example how whole process could be automated, but take into account, as I already mentioned, you need to be ready for this. You need to have tag policy. You need to create special functions to the for the CloudFormation to create this clean room or automation. How to remove the scaling, how to snapshot, how to copy snapshot to the hard drive without changing, without losing the data, etc. How to isolate the instances, placing them into security groups or isolated network groups, depends on which cloud you use, etc. And of course, how to run automatically the basic forensic tools, Autopsy, Slothkit, or in case forensic, whatever. But all these tools today, they have a CLI, command line interface, and you could launch them with some scripts. So also, you need to be ready for this. According to this, according to my words, I would like to conclude that the forensic readiness today, it's looks like 70 or 80% of success in cloud forensic. If you will miss something during your preparation, if you will miss configuration, tagging, resources, policies, or even licensing, if you will miss the necessity to buy a network watcher or to extend your license for the log retention or for the S3 bucket, sorry, but you could lose the data and your forensic will not be succeed. So, of course, in our course, we will deliver more extended lectures and practices according to the cloud forensic, and of course, cloud forensic readiness. We'll discuss all these points. Our trainers will be Anders Karlsson, Dr. Anders Karlsson as well, is an expert with more than 30 years in cybersecurity and forensic. He was the investigator of Locker, Goga, NotPetya, and others. And me, Dr. Oleksii Baranovskyi, I am also cybersecurity expert with less experience, but one of my focuses is forensic as well also. So I do believe that we will deliver a best material with best practices and satisfy all your requirements. So thank you, and I'm ready for your questions.